Hello grade 10s, let's have a look at these starter questions from the booklet. Hopefully you've had a go at them and you're just checking through. There might be some where you want a little bit of help with parts of them. So the first question, 1a, we are going to apply this power of 4 to both the 2 and the a to the power of 7. So we're going to get 2 to the power of 4, and then when we raise a power to another power, we multiply them, so it'll be 28. We should be able to work out 2 to the power of 4. It's just 2 times 2 times 2 times 2, which is 16. So there's a simple way of writing it. Part B, there's a few ways you could work on part B. You could apply this power of -1 to everything in the parentheses, which would absolutely work, and you could then think about moving all your negative powers around. However, as we're going to be applying a power of -1 to this whole fraction, and what that's going to do is do the reciprocal of it, an easier way is just to move our denominator up to the numerator and our numerator down to the denominator. That's used up the negative in this power. The power of 1 that's left doesn't have an effect. So if we approach it in this way, it's actually quite a quick, straightforward problem to look at. Then moving on to part C, I think I'm going to try and simplify the numerator first. So I'll multiply the 4 and 6 together, and then I'm multiplying with the same base, so I'm going to add my powers to get a to the power of 12. Oh, and look, we've got a to the power of 12 in the numerator, which can cancel with a to the power of 12 in the denominator. Then all I've got left to simplify is 24 over 8, and that is 24 divided by 8 is 3. Moving on to question 2, I hope you have all got your calculators and you have graphed 3.2 to the power of 2x and x plus 2 all squared. This one is a little bit tricky. There are actually 3 intersections. To make this a bit easier, I think I'm going to do a bit of a sketch of this. So let's have a sketch here, which I will eventually need anyway to show my workings out, but we'll have a sketch. And we've got our parabola, which meets the x-axis. Oops, let's try again. So the parabola meets the x-axis here, and then we have our exponential equation, which does something like this. Okay, so there are two intersection points which are very close together, and then you really have to scroll up a bit and you will find that there is a third intersection point up here, because our exponential function increases at the rate of increasing just keeps growing, and so it actually catches up this quadratic function and passes it. So once we've found where all of these are roughly, it means we can then use our calculator to find the points of intersection. So we get x equals 0.922, x is equal to, let's find the next one. Bear with me. Okay, my next intersection point is -1.89, and my final one -2.09. So there are my 3 solutions.